How's it going? Earlier, we saw that the chain rule can be used to differentiate a function that is made up of the composition of two functions. So one way of expressing this, dy over dx, is the same as dy over du times du over dx. This was if we had y as a function of u as a function of x. All right. Now, we can also use the chain rule to differentiate a function that is made up of the composition of three or even more functions. If we're dealing with a composition of three functions, we might have dy over dx equals dy over dv times dv over du times du over dx. This is if we have y as a function of v as a function of u of x. So if we have three functions that are compositions of each other. Let's look at an example, because I think that it's a lot clearer when we have an example instead of all of these different dy's and dv's and du's and dx's and everything. So let's consider y equals sine of cosine of tangent of x. So this is three functions in a composition. The inner function is tangent of x, and then we take the cosine of that, and then we take the sine of that. So this is a composition of three functions. So what we would do here is we would start with the inner function with our substitutions. Let u be tangent of x. Then when we do that, we've got y equals sine of cosine of u. Then we can let v be the new inner function, cosine of u. If we do that, then y equals sine of v. And once we've made those substitutions, we can go through and apply the chain rule here. In that case, dy over dx is dy over dv times dv over du times du over dx. So that's the derivative of y with respect to v. Well, we know that y is sine of v, so the derivative of sine of v is cosine of v times dv over du. That's the derivative of v with respect to u. If v is cosine of u, the derivative of cosine of u is negative sine of u times du over dx. Well, if u is tangent of x, the derivative of that is secant squared of x. So we've got cosine of v times negative sine of u times secant squared of x. But we have to write everything in terms of x. We don't want u's and v's in our answers. So if we look at cosine of v, well, we know that v is cosine of u, but u is tangent of x. So v is really cosine of tangent of x. And so this becomes cosine of tangent of x times negative sine u. But remember, u is tangent of x. So that's going to be times negative sine of tangent of x, and then times secant squared x. All right. The last thing I would do is I would take this negative and move it out front, which is a little thing for a whole nother row of work, but let's do it. Negative cosine of tangent of x times sine of tangent of x times secant squared of x. And that is what we end up with. Now, the thing is, we don't have to write out, once we're used to it, all of these substitutions, because basically what this is saying is we are differentiating the outermost function times the derivative of the middle function times the derivative of the inner function and evaluating them at whatever was originally inside of them. So if we look at this original thing, y equals sine of cosine of tangent of x, the outermost function is sine, and the derivative of sine is cosine. So if we start on the outside, differentiating sine, we've got cosine of all of that, cosine of tangent of x, times, and then we move inside one function. The next one is cosine. The derivative of cosine is negative sine of whatever's on the inside, tangent of x, right? The derivative of cosine of u is negative sine of u, so it's going to be negative sine of tangent. And then times, I'm going to put all that in parentheses because I don't like having a multiplication next to a negative like that. And then times the derivative of the innermost function, the derivative of tangent x, is secant squared of x. And we get the exact same answer that we had before, but we don't have to write out all of those various steps. We can do it really quickly and easily, and yeah, not that much work. So once we're really comfortable with the chain rule, we can do things really quickly and easily. I want to do one more in this video just so we get a little bit more practice. So let's differentiate y equals e to the secant of 3 theta. Now this is a composition of three functions. The outermost function is e to the v, and then the middle function v is secant of u, and then the inner function u equals 3 theta. Let's differentiate from the outside in. Well, the derivative of e to the v is just e to the v, so that's going to be e to the secant of 3 theta, times the derivative of the middle function. The derivative of secant of u is secant u tangent u, so we've got secant 3 theta tangent 3 theta, times the derivative of the innermost function. We've got u equals 3 theta. The derivative of that with respect to theta is 3. And so we end up with that. And I know it's a lot to rewrite this just to move the coefficient out front, but it looks nicer. We end up with 3e to the secant of 3 theta times secant of 3 theta times tangent of 3 theta. And that is our derivative. So once we get good at this, we can go through these pretty quickly and easily.